Welcome to Let's Do It 1.10 or LDI 110. In this LDI, we're going to take a look at three different studies: Study A, Study B, and Study C. In Study A, we have a null hypothesis that the true average lifetime is greater than or equal to 54 months. The alternate is that it's less than 54 months, and we have a corresponding p-value that goes with this study of 0.025 or about 2.51%, okay? In Study B, we've got the average time to relief for treatment 1 is equal to the average time of relief for treatment 2, versus that the time to relief for treatment 1 is not equal to, we're going to read that in a bit, the average time to relief for treatment 2. And corresponding p-value in this study of less than 1%, 0.0018, okay? In our third study, Study C, the true proportion of adults who work 2 jobs is less than or equal to 33%, versus the true proportion of adults who work 2 jobs is greater than 33%. And in this last study, we had a p-value, a large one, of 35.9%, okay? All right, so what they ask us to take a look at here is, first of all, is for which study do the results show the most support for the null hypotheses? Explain. Okay, now remember what we've talked about is that when you're talking about support for the null hypothesis, then what that meant is that I failed to reject the null or I'm accepting the null. Now, when does that occur? Well, that occurs when we have a rather large p-value. Large p-values support the null hypotheses. So of the available p-values that we have here, if you take a look, the largest of these, or shows the most support for the null hypothesis, would be Study C, okay? All right, so let's go ahead and put our answer in here. For which study do the results show the most support for the null hypothesis? The study, I want to say duh, I just want to say study. Study C, since it has a rather large p-value. Okay? All right, so let's take a look at Part B here. What does Part B say? Well, in Part B, we say, suppose Study A concluded that the data supported the alternate hypothesis that the true average lifetime is less than 54 months. But in fact, the true average lifetime is greater than or equal to 54 months. So the data, what did the data do? It supported the alternate, okay? So if it supported the alternate, that must have meant that we rejected the null hypotheses. But what they're telling us is that the truth here is really that the average lifetime was greater than or equal to 54 months, which was the null hypothesis, okay? So what we did was, in fact, reject the null when it was true. And whenever we do that, or when we accidentally do that, which we typically won't know whether we did or not, we have committed a type 1 error. We rejected the null hypotheses when in fact it was true, okay? All right, now I've been informed that this one here is, this Part C that's on my slide is actually different than what is in your textbooks. Apparently they updated it since they sent me this, but that's okay. Let's roll with the one I have, and you can do the one that's in your textbook that's slightly different, okay, on your own. So if the results of Study C are not statistically significant, which hypothesis would you accept? So the results of Study C are not statistically significant. So let's go back and check out Study C for a quick second here. So in Study C, they said the results were not statistically significant, which makes sense because why? Well, look at the p-value, it's rather large. So if they were not statistically significant, then we would end up supporting the null hypothesis, okay? So let's go back and type that up here. So, yeah, we would say, then we would support the null hypothesis. Okay, looking good. Okay, so last but not least, we've got Part D here. Part D says, for each of the study, determine the rejection region that would have been one-sided to the right, one-sided to the left, or two-sided, and circle your answer. So let's go back and check out our hypotheses again. Now, it turns out that there's a very nice little thing here. If we take a look at the alternate hypothesis, it's always going to be the hypothesis that tells us the direction of extreme. And as a matter of fact, the inequality symbol will make an arrowhead pointing in the direction of extreme. So in the case of Study A, the alternate says that the average is below the average that was given in the null, which would make it one-sided to the left. In study B, we said not equal to, as I underlined that earlier. So what that means is a not equals. Whenever you have a not equals, you don't know whether it's to the left or to the right, so that's a two-sided test. Okay, in this case here, we have a greater than, and again, notice that that's creating an arrowhead pointing to the right, and gives us a right-sided test, okay? But we know that because the alternate is saying that the value is larger than it was in the null, which means it's to the right of the value in the null, okay? So let's go ahead and do our circling here. So we've got one-sided to the left for study A, right? See how that works, okay? And then we've got two-sided for study B, and we've got one-sided to the right. One more time, let's go take a gander at it, for study C, again because the inequality symbols are just a nice trick helping us out figuring out which way to go there. Okay, well, hopefully that takes care of this LDI for you. If you have any questions, please don't be shy about posting questions to the forum, or if we're not getting to the forum quick enough to help you with the questions, don't be shy about firing us an email. And we do take requests. If there's any problems or LDIs you'd like to see done up as a video, please send us an email and we'll get after doing those for you.